All right. Once again, thank you for joining us, those that have joined us live today and at this time. We're going to take you through an introduction and a presentation and a small demonstration. We'll see how that goes live within a live broadcast. We will see, and should take about 30 minutes. But first of all, just a little, but not even intro, but just to let you know who's at the other end of this thing. So I'm Maurizio, the one that is wiggling at the moment. On the right-hand side, well, there is my name there, so you can point to that. And we have Peter, who's gonna say something so you can associate his voice.
Good afternoon, everyone, and welcome. Thanks for joining us.
Just a quick introduction about who we are and what we do. For those of you that don't know us, or know us a little, we're a 5 years old company now. Actually, in February, I think we turned 5, thereabout. And we operate from, we are based in Adelaide, actually right in the center of the CBD, I would say, which is very nice and convenient for us. We are a mix of engineers, mechanical engineers, programmers, and the likes. And because of our background and the projects that we have run in the past, we get involved in a wide variety of projects. But our specialties or specialization is test and measurement and data analysis. We do have a background in noise and vibration. In fact, the majority of us in the team have had some involvement in noise and vibration in the past. But we are not limited to noise and vibration. We have carried out some weird and wonderful projects as well, not involving noise and vibration whatsoever. We can summarize what we do in 3 major domains. The first one, monitoring solutions, and it's quite broad in a way. But for example, today is a presentation and discussion on vibration, ground vibration monitoring, which is based on the AVA monitoring solution from Sweden, for which we are the exclusive distributors in Australia. And but we do also offer other type of monitoring solution, noise, kind of an obvious link up for us. But we also have deployed system, for example, for electromagnetic field monitoring and other quantities. We also very much specialize in custom measurement systems. And when you stick the word custom in front of measurement systems, it can mean many things, and it does. So it's a bit difficult in just one page to tell you what all these different custom measurement systems could be. But one example, about a couple of years ago, we have developed a remote actually measurement system to monitor strain and structural integrity of train bogies over a period of 8 to 12 months. So it was fairly custom in the way that the solution fitted the requirements, and also the fact that it was remote, with not remote access at all during the operation. The more traditional part of it was the fact that he interfaced a number of strain gauges instrumented on the train bogie. There's many other examples we could touch on, but perhaps another time. And we also get involved with pure data analytics. We have developed, for example, data cataloging databases and data mining tools, still in the analytical and measurement and sampling field business. But another example in the noise and vibration, since we're talking about vibrations today, a while ago we developed a QA, a quality assurance tool to be used in the field to validate measurement for a client that had numerous measurements to do per day and in the field, and no way of knowing if the measurements were okay or not. So that was it's still a custom solution, but purely on the data handling. Okay, so now I am, that's enough from me. I'm gonna hand you over to Peter, which we're gonna give you first of all a quick look on what the points we're touching today, and then we'll crack on. Thank you.
All right, thank you, Mauricio, for that introduction. And once again, welcome everyone to joining in today. So I just wanted to take you through quickly what I will be covering in this discussion. We are, as Mauricio said, we're the exclusive distributor for AVA monitoring products in Australia and New Zealand. So what I wanted to do is run through just a brief introduction to AVA monitoring, what their philosophies are and what their business and how they run themselves. And then look at their main particular device that we stock here, which is the AVATRACE. I want to look at what it is and how it can help you to automate your ground vibration monitoring. Subsequent to that, earlier this year, they introduced a new frequency-based alerting feature. This has been quite a boon for us here in Australia, where a lot of our ground vibration is frequency-based requirements. So I'm going to take you through a brief example of that with a live hardware demonstration as well. So hopefully that all goes well. And then at the end, as Mauricio said, we'll be running a brief Q&A. So if you've got any questions, please feel free to put those in the chat and we'll get to those at the end.
Actually, sorry, I step back in 1 second. I just remember we wanted to put some disclosure first in the fact that this is the first event that we run live. We were hoping to get some bit of equipment for our audio visuals, but because of the current situation, delivery basically did not eventuate. And so the switching between live camera and various windows might be a little bit tricky, so bear with us. But you never know, we might do it.
Thanks to COVID, everyone is now a streamer. So anyway, let's get started. So just to briefly run you through, so AVA monitoring, the AVA monitoring philosophy really is one of simplicity and ease of use. So for those of you who don't know much of the background, AVA is a Swedish company. They specialize in ground vibration systems. So their AVATRACE M80 device, as you can see here, is that little black box on the right there, is the latest in the range of vibration and overpressure monitoring devices, which are targeted specifically at monitoring construction vibration and handling alert notifications and assessment criteria. So the AVATRACE really brought a fresh approach to ground vibration monitoring, and it continues to push this philosophy. So their genuine aim is to simplify the installation and setup process and reduce the time that's required to handle large volumes of data that you might have previously been left to deal with using older systems. So just to take you briefly through the hardware as we stock it. So as I said, the AVATRACE M80, which is the brains of the operation, is this device that's highlighted here. Nice solid pelican case, quite weather resistant, very rugged, designed to be used in the construction field. Highlighted now is a wall-mounted geophone. So these are a triaxial geophone, which you connect to the unit via a 5-meter integrated cable, and that does all your measurement as your sensor. The most typical sensor that we provide with these units for construction vibration monitoring. And at the top left there, we have our in-house designed and built flashing light alarms, which are directly connected to the unit, and they provide visual and audible feedback for triggered events. So just to run you through the basics of the device itself, for those of you who aren't particularly familiar with them. So each AVATRACE instrument has 4 input channels. So each of these channels can be activated or deactivated independently, depending on your input device. So as we saw before, with a triaxial geophone, you'll only be using the first 3 channels of the inputs. So like your standard monitoring device, you have a fully functioning periodic sampling process. So the unit continuously monitors the incoming vibration levels from the sensor in an instrument buffer, and then it stores the highest peak particle velocity, so the PPV, as it's commonly known, per channel for the assigned sampling interval. So this is useful for gathering background vibration data to view trends over periods of time. Now, there might be a tendency to set a small sampling interval to generate sufficiently granular data. However, it will become clear as I go that why this is not necessary and indeed not recommended by AVA, and one of the reasons why they developed this product. So this brings me to the second event storage method, which is the triggered event. So here we can set a trigger threshold per channel as well, above which the instrument will generate a unique time-stamped measurement and will connect to AVANet to upload this data automatically. With this information now available, we can be sure that we are alerted to an event's occurrence and we'll be able to investigate it further. What's important to distinguish here is that you can have one, the other, or you can have both. Both the periodic and the triggered measurement systems work simultaneously alongside each other, as opposed to one being dependent upon the other. This gives the user full control over the capture and storage of events, all the while minimizing extraneous background measurements that can be uninteresting and generally quite time-consuming to wade through during post-processing. So this is the basis of the AVA monitoring automation philosophy. But as I'll take you through now, there is a new method that they've implemented to further extend the possibilities of your autonomous monitoring. By this, I refer to AVA's new frequency-based triggering and alerting functionality. So earlier this year, AVA implemented the frequency-based triggering capability to all eligible MAD devices. This update allowed the application of a fully user-defined frequency-based trigger threshold, say that 10 times fast, fully user-defined frequency-based trigger threshold. So as you can see in the graph, you have control over setting levels for given frequencies. And also AVA has kindly provided a suite of templates for common monitoring standards such as DIN 4150, which is a very, very common standard here in Australia for monitoring. So incoming signals, as I explained before, are analysed in real time on the unit using the zero crossing frequency analysis method. I won't go into the details of that. I'm sure quite a few of you will understand how that system works, but that's the system that it works. So in real time, the unit will use that zero crossing frequency analysis method. And if that guideline level, as you can see as an example in that graph, is selected, you might expect only those events that contain frequency content exceeding the trigger threshold will be captured as unique events, with waveforms available as well for further frequency analysis in post-processing and even oralization as well. So as I'll explain shortly, this functionality greatly improves the quality of the alerting and measurement storage capabilities of the MAD device. By placing frequency rating on triggered events, you're able to focus in on those events that you would consider most important based on whatever your measurement requirements might be. So one of the main functions of the AVATRACE devices is the alerting capability. So the frequency-based triggering option now further refines the sending of exceedance alerts directly from the units. So on the left, we have the standard operation, whereby the channel trigger threshold, so the threshold above which the instrument will generate that unique time-stamped measurement, is set as a whole number, so it's a fixed level. This is useful if we want to have email warning alerts for when we're approaching the criteria. We then have the SMS trigger threshold set at our alerting criteria. So this configuration is fairly common and allows that buffer between measurements and storage thresholds and those measurements which require alerts to be sent. Now on the right, we have the same whole number SMS trigger threshold, but we now have a user-defined frequency-dependent channel trigger threshold. Like I said, say that 10 times fast. So this method works in the same way where the events with frequency content above that teal guideline that you see and above the red SMS trigger threshold will send an SMS to the nominated recipient. However, when you have frequency content in the shaded area and nothing above the teal or red lines below where they intersect, the unit won't trigger and an alert will not be sent. So generally, hopefully this is it just summarily demonstrates how this frequency-based triggering can help to filter out some of those particular events with high frequency information that you may not necessarily be interested in, and focus the attention on important events in the range of interest, particularly in that sort of 1 hertz to 10 hertz frequency range. One caveat with this, I will mention, and it's something that is just a current operation of the system, is that the peak frequency displayed in an SMS alert will be the maximum value for the triggered event. So even though the instrument has triggered due to frequency content above the guideline threshold, using the right-hand graph as an example, you'll get an SMS with a reading of, say, if we look at this, 8.1 millimeters per second roughly at around 950 hertz. Despite this though, if you received an SMS, you can be confident it is because you have exceeded your criteria, and you will always have the option to go into AVANET as well to further investigate and look at graphs, which I'll take you through shortly, to look and such as these that you can see to investigate it further. And I'll be going through that process, as I said, shortly. So these are the two basic differences between the triggering methods and the alerting methods. These are both available on all eligible M80 units, and any new units that are sold will have this functionality. So you always have the option to choose one or the other depending on the requirements of the project, or if you generally need to filter out high frequency content due to inadequate installation options, which we have had with a particular project recently. So just quickly to summarize that a little bit. So as a former acoustic engineer myself and a consultant, I relied heavily on these AVATRACE instruments for ground vibration monitoring and triggering alerts specifically. So one particular challenge was constantly having to go into AVANET to investigate the frequency content of each triggered event and manually notify the client of the severity. And that's based on that fixed trigger level triggering. But now with the frequency-based triggering, you're no longer having to always manually go in and check those triggered events for frequency content, and you can rely more heavily on the unit triggering to be your guide on whether a particular event requires your or your client's attention. So it's really taking a lot of the work that you might have done manually previously and automating that directly from the unit. So this flows onto the alerts that are sent, whereby you can cut down on alarms received by contractors and hopefully improve their ability to continue their work without as many interruptions and having to stop work so frequently. So, and as if it needed any further improvement, any reduction in triggered events will also have a flow-on effect on power conservation. So the main battery draw in the average use of an AVATRACE revolves around network connections. So obviously, if there are fewer connection points and a unit connects fewer times, you're going to see greater battery performance as well. So it's going to save you time going out to site to change batteries constantly as well. So we're going to attempt to just do a really, really brief hardware demonstration of this, just to take you through quickly what we want to do. I would like to basically show a triggered event for a fixed threshold, as we said, so that no frequency-based guideline applied. We'll then change the guidelines and update the settings on the unit so that we then are triggering off of that guideline. Whilst that's happening, we'll view that peak frequency graph for the triggered event, and we'll look at the frequency content, and we'll see what's going to happen if we apply that guideline. And then what happens after that, we'll repeat the drop test, and hopefully what we should see is we shouldn't see the unit triggering. So what we'll do is I'll just get Maurizio just to quickly jump in.
All right, and hopefully we're going to do these switchovers super smoothly. Okay, just bear with us. We're going to go to a live shot on the AVATRACE itself. Okay, so now on the screen.
What you can see here is we have the AVATRACE M80 device open for you, so you can see everything operating as it should. And I think something just happened which has triggered it, so that's always good. So I'll give you a bit of a demonstration. So as you can see, the unit is operating by those flashing lights. Now, what we're going to do is I'm going to come over and using that depth gauge, I'm going to drop this, here we go, this calibrated weight.
Calibrated Sharpie.
Calibrated Sharpie from the 30 centimeters above the desk level. And hopefully what we should see is we should see the unit trigger, which we'll see that little flashing light that you might be able to see there, that will go solid and that will cause the unit to trigger. So let's give this a try. Let's make this work. All right, excellent. So as you can see, the unit's triggering and it's doing as we should expect. If you can go to, so what we might do is we'll just jump over to AVANET and we'll have a look at those unit settings. So if I scroll down, we've got, this is our instrument panel for the instrument. As we can see, we've got that fixed channel threshold. What I want to do now is I want to apply a custom guideline. So once we apply this custom guideline, what should happen is these settings, as you can see, they're currently yellow, which means they're not uploaded onto the unit yet. Once the unit connects, those settings will filter through and our guideline will be applied. So when we replicate that drop test, hopefully what we will see is we'll see no trigger at all. So what I'll do is, once that event comes through, what we can do is we can go into the project, find our vertical channel, because obviously we're dropping that pen straight down, so we should see a vertical exceedance come through, which has exceeded our 3 millimeter a second Here we go. So what's the target? That 153.08. So that looks like that was our event. So we just exceeded our criteria by 11.11 millimeters per second. So if we go into this waveform, simply by clicking the tick, we can have a look at this event that happened. Once it loads up. Okay, so here we go. This is our event. This is the waveform from the unit, which is automatically transferred from the unit. If I click on this peak frequency here, we can see a nice little breakdown of our zero crossing peak frequency points for that particular event. So as you can see, our highest level was 3.1, but it was up around 200 hertz, and we're not really interested in this level up around 200 hertz. We're more interested in this low frequency content. As you can see, there's nothing really happening below, well, 70 hertz essentially. So if I select this custom curve that I've got, as you can see, all of these levels are well below the criteria, but we still triggered the instrument. So what we've done now is as you can see, this graph, this guideline here has been applied onto the unit. So what should happen now, if I go back to my measuring points and I go back to my instrument, as you can see, we've triggered. Now, all of that yellow has gone away, which means those settings have all transferred. And as you can see, we've now gone from this 3 millimeter a second fixed to this custom curve guideline, as you just saw before. So if we go back to our camera and we conduct the same drop test, hopefully what we should see is that we shouldn't see the unit trigger at all. All right, so I dropped it a couple of times just to show, but as you can see, no triggers, which is obviously it's applying that guideline frequency to our triggering events. And so we haven't received any notifications. We haven't received any triggered events. So it's a very simplistic way of looking at it, but this is just a nice and easy way to show you how this particular functionality can hopefully cut out some of those events that you might not be interested in. Obviously, a pen dropping in a table, it's all going to be particularly high frequency. You're not going to get a lot of displacement from an event like that. And so when we're talking about structural damage and we're talking about building construction vibration, that's the kind of stuff that we're interested in. So by being able to remove a lot of that high frequency information from that triggering, we're actually being able to save ourselves from getting a lot of notifications and getting a lot of data sent through and a lot of battery powered usage from those particular events. So hopefully that gives you a nice straightforward summary of how that all works. And yeah, that's kind of what we had in mind for that live demonstration. So hopefully that gives you an idea. If you've got any questions, yeah, do feel free to post them in. But we'll just go back to the presentation now if we can. Excellent. And yeah, I mean, thank you for joining us. That was a nice quick whip through of what the AVATRACE monitoring M80 ground unit vibration unit is. You know, a bit of a description about how it might help you with your automation and some new functionality that they've introduced that has actually improved. And the feedback that we've gotten from a lot of our customers and clients is that it's greatly improved their ability to put more reliance in the system and trust its autonomousness as well. So.
We do have one question. Mm-hmm. All right. So I'll read it out. So it's about oralization. So are you able to play back and listen to the events?
Yes, absolutely. So there are two ways of accessing the waveforms that come off the unit. It's all done through AVANET. So you can either download the waveform as a text file. So it's basically a wave text file, which you can then load into your engineering software, such as MATLAB or whatever you might use to post-process. And there are scaling factors and all of that in there. So that gives you the option to do that. You can then export it from there as a listenable audio file. Or you can actually, there is a listen function in AVANET as well for those particular events. So you can click on that listen, and what it will do is will download a pre-processed audible version of the waveform that you can then listen to over headphones. Now, obviously, it depends on what your playback system is and how you're playing it back, but in my experience, I've actually found this quite useful for particular events and listening at frequency content. So if you're getting a measurement come through and you listen to it and it sounds like a lot of high frequency information, and it's actually a good way of identifying too, potentially what the sound source was or what the vibration source was. So yes, absolutely, you can download the waveforms and post-process and export, or you can export them directly from AVANET as a listenable audio file.
Okay, great question. Thank you. Thank you all, and stay safe.
Yeah, thanks for joining us.
Thank you again. Goodbye.